Hello everyone, we are back to talk again a little bit more about autoencode and latent space. And in the previous lesson, we saw that we can use the latent space to do some transformation to our images. And in this lesson, we are going to see another example where we can leverage from this latent space that we get from autoencoders. And this time, we're going to see how we can use latent space to search for image similarities, and build one image search. So starting again, so we have some parameter here, nothing has changed from the previous lesson. Data load as well, we're going to skip. So the same it is to for encode for our model encoder. So this is everything that we saw before. And here we are going to need the data that we generated before. So we are gonna, when you were training our autoencoder in our previous lesson, we generated two assets, which is basically the weights for the model itself. We are going to skip the training and just load what we trained before, and in order to upload this into Colab, we have to click here on this icon here, and then we have to create a new folder called assets that we already did here, and then import upload into Colab what we have already added to our project here, assets, and they're going to be uploading these two files here. Okay, and since we are going to have already our let's say weights available, you can just continue and do what you need to do to achieve what we are trying to do here, which is create a image search. The first thing we're gonna need to do it is to create embedding, or basically save all the outputs, all the encoded output for each image. And just remembering what we had before in the previous lesson, we are generating a latent space to the image, and what we're gonna do is generate a latent space to all image in our data set and save it. And this will be done by this function here, create embed. So we're gonna go through, iterate through all the images, and we are gonna be creating encoded data for each image, and then we are going to stack in a row all the encoded data. Okay, and this would be working as a database for our searching. This is basically creating the encoded and create and saving in an index to later being searched by we are going to give an image and be searching on this database that's called or index of embedded data. We have the option to save it as well if you wanna if you need to skip this step. It's not it doesn't take long, but we have the option here, but I commented it. Basically this index would contain features for each image, right? So the encoded data contains let's say details of the original image, right? And you store it, and we could be using this data and applying on a TNSA algorithm and see the visualization of the data. For example, we could translate this whole data that we are saving here in using this algorithm and see and trying to group all the similar images in different let's say groups in a cluster, and this is basically what is behind our search, right? So we can apply some algorithm to kind of look at the data that from our image, which is the features or encoded data or latent space or all that. It's to say the same. But since we are talking more about, we are naming that as latent space, let's say that based on the latent space, we are able to calculate similarities or how close each image it is from each other. So if you want to work on this data and try to plot it, you would see something like this. Since we can see that you can calculate similarity, we are able to kind of get do our search pretty easily. And about this, how you calculate similarity, I think that is the most important part here. And in order to calculate a similarity, we use a simple algorithm called Euclidean, and this will give us the distance between not two image but two latent space. Okay, and our Euclidean is basically using a NumPy function. It's available. It's one line that we need to write in order to get that. And we have this perform search, which it's given on the database and the query image that you are querying. And just pass this. We go through all the images in our index and check the distance between our query image and the image that we are looking in the loop, and we store all the distance, and we keep the index of that given image that we got the distance, and we just sort based on the distance, and from there we can just take on the top, it is the closest one. We have also the same get similar images, which we are just doing in code before, and calling the perform search, which is the function that we just look at. And it's pretty much that, and that's all we need to do. We create an embed, put everything in the index, and then we iterate through each item in our index and calculate the distance, right? And the magic is inside this algorithm here, which it is not important for this course, which is very mathematical part, and you just know that this algorithm is there available to calculate distance. There is other algorithms, for example Gaussian and others, so you have some option to use that. And just following our example, we're gonna now take one example here. We take the image the number 7 and display it here how it's the image that we are using as the query image, and we get the similarities, the image similarity from our index, and then we get a list of 10, so we pass how many we want to get, and we return 10, and you can see that it's 7, and the data that we responded is just the distance and the index of the image that it's closest. Okay, so from there we can just iterate in our index and get and display all the image that is similar to the one we are looking at. So in our case here we have 7, and all the 7 it's slightly different, but it's very close to the original image. And with a very simple approach, we're using leveraging from autoencoder and latent space, we are able to build a pretty nice app where we can like search for similar images. Okay, so that's it. Hope you have enjoyed this example, and see you next lecture.